So the final equation in slope-intercept form for number 13 is negative 2x plus 1. Because negative 10/5 simplifies to negative 2, and 5/5 simplifies to 1. And we know that the number in front of x always gives you your slope. So your slope is negative 2. Okay, so that's the slope for the first line. Now we have to find the slope for the second line and decide if these two lines are parallel, perpendicular, or neither. So again, we want to get y equals by subtracting 16 to both sides, and we get negative x minus 16 equals 2y, divided by 2, and that's negative 1/2 x minus 8. So if the slope for this is m equals negative 1/2, and the slope of the other one is negative 2, they are reciprocal, but they're not opposite. They both have a negative sign. So they're not perpendicular, because perpendicular has opposite reciprocal, not just reciprocal. So for number 13, the answer is neither. Okay, and I'll erase number 13. When we get to 15, give you a chance to write it down. For number 14, again, we're going to get y equals by isolating the term that has y in it. Isolate the term that has y in it by moving x to the other side and divide by negative 6. Okay, so that line would be negative 8x over negative 6 would be y equals 4/3 x minus 7, with our slope being 4/3. Okay, and then in the other one, all you have to do is divide by negative 3, and that gives us y equals negative 3 plus 4/3 x, because the negative over the negative turns to a positive, and we can write that in slope-intercept form, but we do know that 4/3 is our slope, and they have the same slope, so they're parallel. Okay. Number 15, let's get rid of all this. And we, again, want to get y by itself. We can add 8x to both sides, so we get 8y equals 8x. When we divide by 8, it actually cancels out in both of them, and we get y equals x, which gives us a slope of 1. Here, if we subtract x, we get negative y equals negative x plus 4, divided by negative 1 everywhere, so that the y is completely isolated, and we get x plus 4, which also has a slope of 1. Therefore, they are parallel. That might have too many L's. Okay, number 16 is a special case. I'm going to graph it for you so that you really see what's going on. The line x equals 2 passes through where x is 2, so approximately right here. I'm not worried about where it is. What we are concerned about is that it's a vertical line in comparison to y equals 2, which is a horizontal line passing through where y is 2. So the green line has a slope of 0. If you remember, the top of the z makes 0, and the red line has a slope of undefined. And these are technically perpendicular. Okay, let's move on to the next section, x and y intercepts. That point at which the graph intersects the x-axis is called the x-intercept. So we know that is this point right here. Likewise, the point at which the graph intersects the y-axis is called the y-intercept right here. Identify the x and y intercepts of the graph shown at right. We just did that. This is our x-intercept, and this one is our y-intercept. The x-intercept is also referred to as a 0 because y is 0 at that point, a root, like a tree where it goes through the ground, and we could call the x-axis the ground, or a solution, because we're always trying to solve for x, right? And that's what that is, to the equation. To find the x-intercept of an equation, set y equal to 0 and solve for x. To find the y-intercept of an equation, set x equal to 0 and solve for y. You can also use these points to graph the equation. So notice in this example right here where we identified the x and y-intercepts, if I plotted the x-intercept and I plotted the y-intercept, I could connect those points to make a line. So you don't need to write the equation in slope-intercept form if it's not already, because you could just find the x and y-intercepts and solve. So for this example, it happens to be in slope-intercept form, but it says to find the x-intercept of an equation, set y equal to 0 and solve for x. So let's set y equal to 0 and solve for x. And this is to find our x-intercept. So we're going to subtract 5 on both sides. We get negative 5 equals negative 2x divided by negative 2. And x equals positive 5 over 2 because it's a negative divided by negative. That's our x-intercept. And if they ask you for the x-intercept, just write 5 over 2. If they ask you for both, make sure that you label which one is which. Same thing to find the x-intercept, we're going to set, or the y-intercept, set the x equal to 0 and solve for y. So let's look like this, which happens to be a little bit easier because negative 2 times 0 cancels out, and we get y equals 5. Okay, let's do the same thing in number 1, but this time we're going to use the intercepts to graph. So to find my x-intercept, I plug 0 in for y, and to find the y-intercept, I plug 0 in for x. And we know the y-intercept as that constant because it is in slope-intercept form, but we're following the process for now so that when we get to standard form, we know what to do. So we're going to add 1 to both sides. 1 equals 5x divided by 5, and you get x equals 1/5, which is a number a lot smaller than 1, so we're going to put it pretty close to the x-axis. Not really a great way to graph. If you know the y-intercept is -1, I know that you guys also know that you could just use the slope of 5 to graph this line. So that might be easier. And if you have a ruler, that would be great. If not, nice and neat. Okay, I'm going to leave number 2 for you because it's in y equals mx plus b. So you can decide to graph that using the fact that it's in y equals mx plus b or finding the intercepts. What's important is for ones like this, where we can plug in 0 for x, and we get 2y equals 4, which means y equals 2. And we put a point here. And then same thing for y. We get 2x equals 4, and x equals 2. And then you can just connect those points. So that's the idea when it's in standard form, that you can just graph them. But I'm going to leave you to do number 2. When I collect your packet, it should be completed. And I think we have, let's see, just this last section to do.